This is the third lesson on algebraic expressions, functions and iteration with me, Mr. Riley. Today we'll be learning about rearranging formulae and inverse functions. This is the stages of today's lesson. First of all, we will change the subject of a formula. Then we will look at inverse functions, do a tick or trash, and then do some problem solving questions. Higher extension today is rearranging the subject of a formula where factorization is required. Explanation: multiplicative reasoning. 3 is equal to 6 divided by 2. Quite obvious for us, but that relationship, when you're familiar with numbers, I could have used different numbers, is really fundamental to a lot of the mathematics you do. And those students getting the best grades have good multiplicative reasoning skills. Now what I need to do is to transfer that knowledge you've got of 3 is equal to 6 divided by 2 to help us out with speed, distance, time, or with trigonometry, or with direct and inverse proportion, although in those cases we have constants as well as variables. Let's take a look. So if I know that 3 is equal to 6 divided by 2, I know that 3 times 2 is equal to 6. I also know that 2 is 6 divided by 3. Let's look at this right hand side. I've got speed, distance and time. We looked at that in our prior knowledge. Well, if I know that speed is distance divided by time, I also must know that speed times time must be equal to distance. And what else do I know? Well, I know that time must be equal to distance divided by speed. Now, the one on the left in red, we kind of do without thinking about it. But in terms of algebraic steps, that first step there, what we're actually doing is multiplying both sides by 2. Those 2's cancel out, leaving me with 3 times 2 on the left hand side. On the right hand side, I've just got 6. If we consider our variables, our speed, distance and time on the right, what I've actually done there is multiply both sides by t. Again, this cancels out, and I've got speed times time, and we can see that underneath. The second stage, going back to the left again please, I'm doing 6 divided by 3, and again divide by 3 on the other side. Times by 3 and divide by 3 cancel out, giving me the 2, and 6 divided by 3, well, that is just shown underneath, that is 6 divided by 3. On the right hand side, what we've got is s times t, opposite of timesing by speed, is to divide, and again that is shown underneath, distance divided by speed. So those skills of being able to play around with the variables is what we need to do to be able to get the subjects of formulae. So now we can look at this in terms of trigonometry. I'm not going to be teaching trigonometry today, that's for a later unit. You might have seen it in year 10, but we are basically doing the same sorts of things really. So if I just want to change the subject of the formulae, again a quick recap: 3 is 6 divided by 2, so 3 times 2 is 6, or 2 is 6 divided by 3. You can look at the previous slide to see where those steps have come from. So on the right hand side, in any triangle ABC, where A, B and C are lengths of the sides and C is the hypotenuse, we've got that sine A is A over C. You might have seen this as, for example, hypotenuse and C, and A would be, well, it depends really, wouldn't it? We'd need our angle. Well, here our angle is A, that's up here. If there's little a, that's the opposite. But this is a bit of a more formal representation of this, but you know, we can quite simply look over to the left hand side to help us. So 3 was equal to 6 divided by 2, so 3 times 2 is 6. So I can say again C times sine A is equal to lowercase a, and I can also say that C must be A divided by the sine of A. Compare what I've got on the left in red with what I've got on the right in purple. Press pause and try the example questions, then press play and I will answer the examples with you. So for question 1, I have pressure, force and area, denoted by P, F and A. Make A the subject of the formula. So P equals F divided by A. I want to get A on its own. That division by A is an issue, so what I'm going to do instead is to multiply by A. I'm multiplying both sides by A. So we get that P times A is equal to F. So if it asks for F to be the subject, I'd be pretty much done now. I'll just go F equals P times A. But I'm asked to make A the subject. So now, opposite of times by P, divide by P. Let's make that a different colour actually so we can see clearly. Opposite of times by P, divide by P. That cancels out and we're simply left with A equals F divided by P. And that's complete. Question 2. Make C the subject of the formulae. Cos A is equal to B divided by C. So opposite of divide by C, times by C. So I have C times cos A equals, these two cancel out, B. If I wanted to get B on its own, I've done that, but it asks for C to be made the subject. So I've got C times cos A. The opposite of that is to divide by cos A. So divide this side by cos A as well. These two cancel out. So I'm simply left with C is equal to B divided by cos A. And I'm finished. C is the subject. Press pause and then complete the independent work. Then press play and I will reveal the answers. Explanation. Rearrange the subject of a formula or equation. Rearrange the following equations to make x the subject. Question 1. You've got w equals y divided by x. The division of x is an issue, so what we're going to do is do the opposite of that, which is to multiply by x. We do it to one side, we do it to the other. So I've now got w x equals y. I can see that these two cancel out, and on this side I've got w times x. Now I've got w times x equals y. So to get rid of w, we divide, which is the opposite. Opposite of times by w, divide. I do the same to the other side. Now I can see on the left hand side I am just left with x, and that is equal to y divided by w. And we can see that on the left hand side those cancel out because they're the opposite. And that's my answer. And this looks very much like what we've just done when we're manipulating distance, speed, time or mass density volume formulae. I'll look at question 2. And that probably looks a bit more familiar, especially in terms of, if I'm solving an equation, I might have something like 2x plus 5 equals 17 or something like that. And again, we use very similar methods. So that 5 is what I'm going to deal with first. So I do the opposite, which is to take 5, but I do the same to both sides. So we've got 2x, the 5's cancel out, plus 5 and minus 5 are their opposites. That equals y minus 5. Next step, I want to get x on its own, make x the subject. The opposite of timesing by 2 is to divide by 2. Whatever I do to one side, I do to the other. Now, do I divide y by 2 or the 5 by 2? Well, the answer is both. Okay? We divide everything on the right hand side by 2. These cancel out, leaves me with x is equal to y minus 5 over 2. Let's make that equals clear. Okay, so we've got question 3 now. The answer was done. Question 3, and the biggest issue here is that take away x. So what I'm going to do is just do the opposite. So we're going to add on x, do it to one side, I do it to the other. So the left hand side I'm just left with 6, these two cancel out, is equal to y plus x. And now I've got y plus x, so the opposite of adding on y is to take it away. I need to do it to both sides. So we've got 6 minus y is equal to x. Traditionally, we normally write the x first, so I can just write it down like this. To show that x is the subject. Okay, let's have a go at some questions on the next slide. Press pause and try the example questions. Then press play and I will answer the examples with you. Rearrange the following equations to make x the subject. Question 1. Y equals 7x plus 3. So first thing we're going to do is look at the 3, do the opposite. Y minus 3 equals 7x. Next thing, I want to get rid of that times by 7. We divide by 7. I do it to one side, I do it to the other, and we do it for everything. Those would cancel out, and that is going to leave me with x is equal to y minus 3 divided by 7. X is the subject, the answer is done. Let's look at question 2. Now what's causing me the greatest issue here is this negative 2x. So what I'm going to do is do the opposite. We add on 2x. If I do it to one side, I do it to the other. So we've got 2x plus y is equal to 10. And I could have written that as y plus 2x. It doesn't really matter. And now I'm looking at, to get x on its own, I need to get rid of that y. So we've got 2x, these cancel out, is equal to 10 minus y. Final step, I want to get rid of that times by 2, so we divide by 2. And that's my answer. And I can, if I wish, rewrite that out. Just to make it very clear. Press pause and then complete the independent work. Then press play and I will reveal the answers. Rearrangement, first step. What would be the first thing you do to make x the subject of the following equations? Question 1, y equals x minus 3 divided by 5. Question 2, y equals x divided by 5 minus 3. So you can see these two questions look pretty similar, but of course the first step is going to be different. So how do we decide what to deal with first? So if I'm trying to isolate x, do I get rid of that 3, the negative 3, or the division by 5? Well, what I can see from the first one, the first question, is that this division by 5 affects everything. That division by 5 captures both the x and the minus 3. So that's what I'm going to deal with first. I'm going to times both sides by 5. Okay. Whereas if you look at question 2, that division by 5 only deals with that x. Okay. So we can see that that minus 3 is separate. So that's going to be dealt with first. And what's the opposite of minus 3? Plus 3. Whatever I do to one side, we do to the other. So that's how I'm deciding what to do as my first step. Okay, so let's just carry that on now. So I'll show you how to finish those off. So question 1, we've got 5 times y, which is going to give us 5y, equals x minus 3. Next step, I've got take away 3, opposite plus 3. I do that to both sides. So I've got 5 y plus 3 is equal to x. And those two cancel out because they're the opposites. Let's look at the right hand side. I've got y plus 3 for question 2 equals x divided by 5. That just falls down. And I can see that plus 3 and the minus 3 cancel. Now that divide by 5, the opposite is times by 5. Again, I've got a decision to make. Do I do y times 5 or 3? Well, the thing is we do both, and we show that with a bracket. So I've got 5 bracket y plus 3 is equal to x. That's now isolated. Let's look at question 3 and 4. So we've got squaring and adding 10, but they're done in a different order. If you look at question 3, that square only affects the x, whereas for question 4, the square affects both because they're in that bracket. So what's the differences in how we start? Well, I can see for question 3, that 10 is separate from that square, separate from that x. So that's what we'll deal with first. I'll take away 10 from this side, so I'll take away 10 from the other. And if I look at question 4, that squared affects everything, so we do the opposite, which is to square root both sides. Okay, so let's go back to question 3. I'll show you how to finish it now. So we've got y minus 10 equals x squared. Plus 10 and the minus 10 cancel. And the opposite of squaring is to square root. And again, do I square root the y or the minus 10? Well, the answer, of course, is both. And I show that using that long root. So let's write this out again. Got square root y minus 10 is equal to x, with those two cancelled. Question 4, take a look with the red writing, we've square rooted both sides. So on the left hand side, we've got square root y equals, well, these root and the square cancel, leave me with that x plus 10 in the bracket. But actually, I've only got one of those brackets, so we could just leave that out. Next step, I've got x plus 10, so we do the opposite. We've got square root y minus 10 equals x. And that's done. Look at the differences between the answers. I can see on the left hand side the square root affects everything, whereas on the right hand side that square root of y for question 4 only affects the y. Okay, so the question 3, that green root is both the y and the minus 10. Question 4, that red square root is just the y. Let's move on to question 5 and 6. So again, what's the differences? Well, in 5, that square root captures everything, both the x and the 3, whereas for question 6 the root only gets the x. Okay, so because this square root catches everything, we're going to deal with that first. What's the opposite of square rooting? Is to square. Okay, and for question 6, that 3 is separate. So what I'll do is deal with that first. Take away 3, take away 3. Let's go back to question 5, finish it off. So we had y squared equals, the root and the square cancel, x plus 3. What's the opposite of adding on 3? To take away, but we do it to both sides. So I have y squared minus 3 equals x, and that's cancelled. Question 6, we have y minus 3 equals square root x, with these cancelling. Now I want to get x on its own. We do that by squaring both sides. Again, do I square the 3 or the y or both? And it's both, and we show that with a bracket. So you have bracket y minus 3 squared equals x, and these two are cancelled. Let's have a go at some questions on the next few slides. Press pause and try the example questions, then press play and I will answer the examples with you. Rearrange the following equations to make x the subject. Question 1. Y equals x minus 6 all divided by 7. So that divide by 7 captures everything. So we do the opposite, which is to times by 7. 7 times y is 7y. Division and the multiplication cancel. So you have x minus 6. Next step, what's the opposite of take away 6 is to add, but we must do it to both sides. So I've got 7y plus 6 equals x. And now we can write that out in our traditional way. X will be equal to 7y plus 6. Just the same thing, but I'm just really clearly showing that x is the subject. Let's look at question 2. Y equals x divided by 7 minus 6. I can see that 6 is separate, so we'll deal with that first. Do the opposite to both sides. Y plus 6 is equal to x divided by 7. Opposite of divide by 7 is to times by 7. Those will cancel. So on the left hand side I'll be left with x. On the left hand side, do I times the y or the 6 by 7? The answer is both, and we show that with a bracket. And now I can show that x equals, so I'll keep the same colour, x equals 7y minus 6. X is the subject. That's my answer. Press pause and then complete the independent work. Then press play and I will reveal the answers. Press pause and try the example questions. Then press play and I will answer the examples with you. Rearrange the following equations to make x the subject. For question 1, we can see that 5 is separate to the x squared. So we'll take this away first. Y, take away 5, is equal to, the 5's cancel out, plus 5 and minus 5 are opposite, x squared falls down. Now, what's the opposite to squaring? Square rooting, but I show it to both sides. And it doesn't just affect the y, it affects the -5, so I draw my long square root. That gives me my next line of working. Y -5 is equal to x, because the root and the square cancel. And that's my answer, which I can show clearly. Okay. Question 2, y equals bracket 5 plus x bracket squared. So that square is affecting everything. So what I must do, because that square's effect captures everything, I must square root first. But I must do it to both sides. So I've got square root y equals the square and the root cancel, the bracket 5 plus x. But I remember I don't actually require that bracket because it's just one of them. Okay, so I can show it like that. So now I'm saying, right, what's the next thing I do? Well, I need to get rid of that 5. So we subtract 5 from one side, we subtract 5 from the other. So I've got square root y minus 5 equals, this cancels out, so it gives me x. So now I can rewrite that. And that question's done. Press pause and then complete the independent work. Then press play and I will reveal the answers. Press pause and try the example questions. Then press play and I will answer the examples with you. Rearrange the following equations to make x the subject. For question 1, I can see that square root captures both the 6 and the x. So because it captures everything, we need to get rid of that first. And the opposite of square rooting is to square. But whatever I do to one side, I need to do to the other. So I can see I'm squaring this. Okay. So we've got y squared equals the root and the square cancel, so I'm just left with 6 plus x. Next step, opposite of plus 6 is to take away 6. So we've got y squared minus 6 equals, that cancels out, so it gives me x. I can rewrite that out now, so x equals y squared minus 6. And there we go. Let's look at question 2. Y equals 6 plus square root x. I can see that 6 is really detached from my root of x, so we can get rid of this first. So we've got y minus 6, that cancels out, leaves me with square root of x. What's the opposite of square rooting? Is to square, but I must do that to both sides. And am I just squaring that? Am I just squaring that 6? No, I need to do it to everything. And we show that with a bracket. So bracket y minus 6 squared equals, that cancels out, leaves me with x. Okay. Unless we're asked to, we don't need to expand that bracket. Okay, and that's done. Press pause and then complete the independent work. Then press play and I will reveal the answers. Explanation: inverse functions. Now we're going to work out the inverse functions below for those two questions. When you see this, it's asking for the inverse function. First of all, what I'm going to do is replace f of x with y, because we're, apart from anything, more used to dealing with that. So we've got y equals 3x plus 5. All I need to do is to rearrange to make x the subject initially. So opposite of plus 5 is minus 5. So y minus 5 equals 3x. Opposite of times 3 is to divide by 3. That cancels out. This gives me x. So let's write that down. X equals y minus 5 divided by 3. Now there's two bits we need to do. I need to replace this x with the inverse, because we wanted to show the inverse function. So I've got f to minus 1 equals, and instead of y, I'm going to replace that y with x, because that's what it was in. It wasn't in terms of y, it was in terms of x. So we have x minus 5 divided by 3. If we're looking at this, you already have most of these skills from earlier in the lesson in terms of just rearranging. So if I only asked you to do this part here, you'd have no problems. The only bit you're really learning to do is here, in addition to what you did previously, and you're just going to replace y with f of x to minus 1 and y with x. That's the only things we need to do. So let's look now at part 2. Again, I'm going to replace f of x with y. So we've got y equals x plus 7 divided by 2. Everything is being divided by 2, so that means I need to multiply both sides by 2. 2 times y is 2y, and that is equal to x plus 7. Opposite of plus 7 is to take away 7. So we will get 2y minus 7 equals x. Let's write that out a bit more neatly. X equals 2y minus 7. Again, nothing up to now is that difficult for you. You know how to do this. You've just got one more step to finish off. So we wanted to find the inverse function. So I put f minus 1 of x, just replacing the x with this, equals 2. Instead of y, replace that with x. Now we can do inverse functions. Just need the extra step and we are there. Press pause and try the example questions. Then press play and I will answer the examples with you. Work out the inverse function of the following. So we've got f of x equals 3 minus 4x. First thing I'm going to do is replace that f of x with y. So y equals 3 minus 4x. Minus 4x, horrible, so let's do the opposite, which is to add 4x. Y plus 4x equals 3. Now I can get rid of the y. Opposite of plus y is to minus y. 4x is equal to 3 minus y. Opposite of timesing by 4 is to divide by 4. 4's cancel, and this is what x is equal to. X is equal to (3) minus y divided by 4. Final step, replace the x with our inverse function and our y with x, and the question is done. Press pause and then complete the independent work. Then press play and I will reveal the answers. Press pause and try the example questions. Then press play and I will answer the examples with you. So we need to work out the inverse function of g of x. We'll start out with writing y equals x minus 2 squared. And we look at what's the inverse of squaring. That's to square root. Do that to both sides. So the left hand side I've got square root of y equals, that will cancel out, so I'll get x minus 2. Next step, opposite of minus 2 is to add 2. So now we're going to get the square root of y plus 2 equals x. Or if I prefer, I can write that out as x equals square root of y plus 2. Final steps, I need to replace the x with, oops, double check your question, it's g of x. Replace the x with my inverse function notation, and that will be equal to square root, place y with x plus 2. Always go back to the question to make sure you're not caught out with something like that. Press pause and then complete the independent work. Then press play and I will reveal the answers. Tick or trash. Read the task below. Press pause and identify which of the 3 solutions is correct. Press play and I'll let you know if you're right. This is the plenary for today's lesson. Press pause and have a go at the task. Then press play and I'll do the task with you. So these two down here, y equals kx and c equals pi d, we're going to come back to these in future units, so I just want to reference them. We've got y is equal to kx, this is direct proportion, and the different ways that I might want to rearrange that, well, I could get x on its own, so y divided by k would be equal to x, or I could get k on its own, so I get y divided by x equals k. And what we've got here is k is a constant, is a fixed value, and y and x are variables. So when I've got that relationship here, y, if I've got direct proportion between x and y divided by x will always be a fixed number, even as they change. There'll be a fixed relationship. Maybe if I take a look at something you'll be familiar with, like circumference is equal to pi times diameter, that will make sense. So at the moment this is set up so I can find the circumference. but what I can do is make it so I can find the diameter instead. So there, how to get diameter on its own? Well, I have to divide this side by pi, I have to divide that side by pi. So we would get the diameter, because this cancels out, is the circumference divided by pi. And again, that wasn't the only way I could have rearranged it. I could have also done pi is going to be the circumference divided by the diameter. So again, that's a fixed relationship. And just as k is equal to y divided by x. So we have pi, that's the 3.14159, so on and so forth, is always a fixed ratio with the circumference divided by the diameter. If you think about it, I could have a larger circle where I've got the diameter and the circumference going around, and if I decrease that, well, the circumference gets smaller, but the diameter does as well. And whenever I divide that circumference by the diameter, I always get that fixed number out. So we're going to take a look at these in future units in a bit more depth and detail. Well done for completing today's main lesson. You are now ready to try the problem solving video and the higher extension video that go alongside this lesson.